Hello there. In this video, I'm going to discuss uh, the medium questions in SMC 4 paper given last year. Now, as you know, SMC 4 paper was introduced last year, so this is the only past paper available. So let's go to those medium questions. Let me share my blackboard and the medium questions. Here they are. Again, let me go over the structure of the competition. So this competition consists of 30 multiple choice questions. And each question has 5 choices. And you have to answer all questions in 90 minutes. And the scoring system is given here. So 5 points for each correct response, 6 points for each correct response in the medium question, so 5 points for each easy question and 8 points for each hard question. All right. So let's go to the questions. So here we are given numbers 25, 47, 13. We need to order them in the descending order. It means that we need to start with the biggest number, and then we need to decrease, put them in the decreasing order, in the magnitude, right? Now here, the biggest number is 47, right? So this descending order, right? It has to start with 47. So we can eliminate the other answers. We have only two choices starting with 47, right? And what's the next number in the descending order? So the 25, right? 13 is the smallest, so that actually is the last, should be the last one. So you can see that this is the numbers in the descending order, given numbers in the descending order, right? So that was quite easy, right? So let's go to number 12. When a digit is placed in each of the square below, which of the following numbers can be obtained as a product? So as you know, we have only 10 digits, right? 0, 1, 2, all the way up to 9, 10 digits, right? So let me write them again. Discuss them in the video on the easy questions. Let me go over them again. So 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So you place a digit in each of the squares below, right? And then you multiply the two digits and you get a product, right? So we are given 5 numbers and we need to figure out which one can be the product, right? So if you look at the numbers, right? So these are big numbers, right? The 115 and in increasing magnitude, right? So the bigger numbers, but you can see that we cannot get a number bigger than 81 as a product, because if you put 9, that's the biggest digit, right, in these two boxes, right? So what do we get? We get 81, right? So we can't get a number bigger than 81. And as you can see, only 15 is the smallest, the number smaller than 81. So it has to be the answer, right? So, and we can figure out how we get 15. Of course, we can get 15 in how many ways? we can get 15 in only one way, right? So we had to put so we have found the answer, but as mathematicians, we need to see we need to go beyond the answer, right? So we could put 1 here, right? Sorry, not 1. We could put 3 there, right? And 5. So that's one way, right? And how about this? So if we put 5 here and 1 here, sorry, 3 here, again we get 15. So you might consider it as different from 3 times 5, but we know that the order in multiplication doesn't matter, right? All right. What about this one? So we put 1 here and 15 here. So the product is 15, but then 15 is not a digit, right? So this is also not correct, right? All right. So let's go to the next question. When a digit is placed in each of the squares below, which of the following numbers cannot be obtained as a sum? So now it is cannot be obtained, right? So here, good thing that not is highlighted, otherwise we might not see it, right? Cannot be obtained. So what is the maximum you can obtain by putting a digit and then calculating the sum, right? Let's see. So we can put 9 into each of these boxes, right? And what do we get? We get 18, right? So we can see that we cannot get 19, right, as a sum. So this has to be the answer, right? So that means all the other ones, right, other given choices can be obtained as a sum. Now, as a curious mind, you need to figure out how can that happen, right? So let's see. So 15. So we can get 15, 7 plus 8, 15, right? And what about 16? So we can actually put 8 here. So doesn't matter, we can put 2 8s, right? And then 17, we can put 9 here, right? And then that's of course 17. And then we can put a 9 here, and then we get 18. So you can see that the other ones we cannot obtain. We can obtain, sorry, right? Right, so that's the answer to number 13. Let's move on. So number 14. Right, as I say, before I discuss and solve the problem, right, you need to pause the video and figure out the answer. And then you have to see what I do, right? So that's how you can get the best from these videos. All right. So here, Kamani's pencil is shorter than Anil's pencil, and Anil's pencil is shorter than Kamani's pencil. So this information, right, we can record this in a very concise manner, right? If you know this symbol, right, this means that less than, right? So 5 is less than 6, right? So we use that symbol to say something is less than something, right? Numbers. So here, Kamari's pencils, I will not write Kamari's pencil, right? I'll simply write K, right? Is less than. So Kamari's pencil is less than Anil's pencil, right? And Anil's pencil is less than Ramani's pencil, right? So this is my shorthand, right? K is less than A and A is less than R. Then of course K has to be less than R, right? Well, that is not what you want, right? Sorry. even though this is true, right? So we need to give the lengths of the pencils in the ascending order, right? Starting from the small to the biggest, right? So it has to be, so from this we can see that it has to be harmonies, um, anils, and ramanies. So that's, of course, the choice A, right? So that's the answer, right? Okay, so let's move on. And here we have a row of apples and bananas, uh, and this is a pattern, right? So this row of apples, right? So apparently this is bigger than what is shown here, right? So something like it goes on, right? Three dots, right? And uh, always apple, banana. So very simple, what we call a sequence. So this word you will hear in um, in higher grades, right? Sequence. Even now, actually, we can talk about it. Sequence, something arranged in some order, right? Sequence. So, how many bananas in the first 99 fruits, right? So, we can, draw these, or we can buy bananas and put them in a sequence, right? And count the bananas in the first 99 fruits. But we are smarter than that, right? We won't do that. We won't even draw 99 fruits, right? We'll figure it out by looking at the pattern. So the pattern is actually, it doesn't change. Always apple, banana, right? So we can see that now, since we know even numbers, odd numbers, right? Um, and of course, we can label these, right? So this is the first one, first fruit, second fruit, third fruit, fourth fruit, the fifth fruit, sixth fruit, and so on, right? So you can see that the bananas actually have even numbers, right? Even numbers. So 99 is an odd number, right? So 99th fruit would be an apple. It would be an apple. And then 98th one is even. It has to be a banana. So in 98 fruits, right, half of them should be bananas because our bananas are at even numbers. So half of 98 is the number of bananas that we have in 98 fruits and also in 99 fruits, because 99th fruit is an apple. So that is actually 49. So that's the answer, right? Sorry. So I hope you understood it, right? If not, pause the video and go over this again, right? All right. We move on to the next question. Number 16. In how many different ways can an apple, a banana, and a mango be arranged in a row? So again, a sequence, right? In a sequence, but only there are three things: apple, a banana, a mango. So in how many ways? So to figure this out, we can actually work with A for apple, and B for banana, and M for mango. So now actually we need to figure out in how many ways we can arrange these three letters, right? um, so so this is one arrangement, and we can keep the apple, right, as the first one, and then interchange these two, so mango, banana, right? And then we can start with mango, and then apple, banana, and keep the M, right, as the first letter, and then here B and A, and then we can actually start with uh, a B, and then A, M, and then we change the last two, M and A. So we made the systematic list. So this is a systematic list, right? We made a systematic list, and we did not miss any arrangement, right? Because the way we actually did this list, right? So you can see that there are 6 arrangements, right? So the answer is 6, right? So we have the answer here, right? Okay, so we got the answer by making a systematic list, right? Now count the multiples of 3 between 1 and 100. Multiples of 3 between 1 and 100, right? So we can um, write them, right? Write the numbers from 1 to 100 and count the multiples of 3, right? So no problem, we can do that, but it takes time and we are smarter than that, right? So we'll find a shorter way doing this, right? So we can, of course, count the multiples of 3, right? Right? So how many are there? So can we do it without counting, right? So this is the last last multiple of 99, right? So you can see that this is actually 3 times 33, right? And what is this? It is 3 times 1, right? So when we take multiples, right? The first one is 3 times 1, the second time is 3 times 2, right? So this is 3 times 2, and this is 3 times 3, right? So you can see that we go all the way up to 3 times 33, right? So from um, so from 1 to 33, 1, 2, 3, 33. So that means there are 33 multiples of 3 between 1 and 100, right? So that's the answer, right? Okay, so let's move on to the next question. Right, now I need to erase what I wrote just now, right? This is not clear. So the following grid consists of 12 small squares of side 1 centimeter. What fraction of the total area is shaded, right? Right. So we can see that 3 of those small squares are shaded, right? And altogether there are 12 small squares it's given, right? So isn't the shaded area is 3 over 12? Because 3 squares are shaded and altogether there are 12 squares. So that is actually 3 over 12. Now we don't see 3 over 12 in the given answers, right? The problem is that when you have a fraction like this, right, you can simplify the fraction, right, by um, taking out the common factors, right? So 3 is actually 3 times 1, right? And 12 is 3 times 4, right? So now you can cancel 3, right? So you get 1 over 4. And of course, 1 over 4 is here. 1 over 4 is here, right? So this is the answer, right? Now, as mathematicians, right, we can think differently, right? So, how about we rearrange these squares, right? Because 3 squares are shaded, right? So does it matter which 3 are shaded? What do you think? Does it matter? I think it doesn't matter, right? As long as 3 squares are shaded, it doesn't matter. So what if we shade these three squares in the first column, right? So this is the first column, right? So the first column is shaded, right? And how many such columns are there? Four, right? So it is one shaded column out of four. See, we got the same answer and we didn't have to simplify the fraction like this, right? So isn't that fun, right? That we do things, in different ways and we find interesting things, right? Okay, so let's move on to the next question. So what digit should replace the letter A so that the following addition of two-digit numbers is correct? Right, so we got one like this as the first problem, right? Now we have actually four A's, right? A, right? Uh, so that means that we add the same number, right? And so it's a two-digit number, essential two-digit numbers, right? So what are these numbers? So these are numbers like 11, right? So 11 plus 11, right? And 12 plus 12, right? So what would give us 198? So it has to be, so if we add the same number twice, right, then that number should be half of 198, right? So what is half of 198? So it's an even number, so we can actually divide that number into, so let's say 198 apples, right? So we can divide that heap into two equal sized heaps. And how many are there? So there has to be, so uh, 99 in each heap, right? So that means 99 plus 99 is 198, right? So A is actually 9, right? Okay, so that's one way. Are there any other ways, right? Well, I think you know how to add these two numbers, right? Two-digit numbers, right? So what you do is that you add A and A. So that has to be, so once you add A and A, right, what we do is that we look at the tens, right? So the tens actually go to the next column, right? The number of tens in that sum, right, goes to this column, and the remainder we put. The remainder is 8, right? Remainder is 8. So what numbers, what two-digit numbers, when added, gives a remainder of 8? Let's see. So it's not, of course, 4 plus 4 gives, right? What else? So 5 plus 5, 6 plus 6, and we go on, right? 7 plus 7, 8. And then we have 9 plus 9, right? Okay. Now, it could be either 4 or 9. So A is 4 or 9. But it can't be 4. If it is 4, then it is 44. Then actually it is less than 100. The sum is, right? Because each one is less than 50. So 44 is less than 50, right? So we can write it, using that symbol, right? 44 is less than 50. And if you take two of them, it has to be less than 100. So the sum is less than 100, right? So this sum, right, is less than 100, but we have 198. So it has to be 9, right? It has to be 9, right? So that also we can find, right? And there could be other ways of finding this A, right? So you need to explore, right? So that's how you should learn mathematics, right? Not just memorize things and do what is in the textbook. You need to go beyond what is in the textbook, explore, right? Okay, so let's look at the next question. So, so we have a nice picture, right? We see a crocodile, he's looking away, it looks like a shy crocodile, and then a lion and a duck. Actually, of course, there are two ducks, right? All right, how many ducks weigh the same as a crocodile, right? So, what this means that this crocodile is weigh the same as a lion and a duck, and a lion weighs the same as two ducks. Then, how many ducks weigh the same as a crocodile, right? So you look at this for a few minutes and try to come up with an answer. So how do we do this thing? So so we can actually use symbols, right? Letters, right? So crocodile, C, right? And the lion is L, and the duck is D. So C is equal to L plus D. So it means that what it means is that crocodile's weight is equal to the weight of the lion plus the weight of the duck, right? Otherwise, it is meaningless, right? C is not equal to L plus D, right? C is a letter, and we cannot add two letters. That is ridiculous, right? But here, what we mean is that the weights, we can add the weights, and L stands for the weight of the lion. D stands for the weight of the duck, right? And their sum is equal to the weight of the crocodile, right? And this is actually this, right? And this is lion is equal to duck plus duck, right? And then we need to find out uh, the weight of crocodile, right? In terms of ducks, right? So it looks a difficult question, but what if we can put the same thing on the balances? So here is balanced, right? So we can actually put the same thing. We can put a line to both sides. The balance will be still balanced. And we can put a crocodile on both sides. Even here, right? We can put anything. But would that help? Well, we can put a duck here, right? A duck here. And then we see that here we have also a lion and a duck, right? Here's a lion and a duck, right? And this lion and duck is the same weight as a crocodile. And then this lion and duck, which is the same as the crocodile, right, is three ducks. So that means the crocodile weighs three ducks, right? Three ducks. So the answer is three, right? So if you didn't get it, uh, go over this again, try this on your own, and then come back and watch the video again. All right. So that's the end of the medium questions. Hope that you enjoyed, and you can see that these questions are more interesting than the easy questions, right? So I'll meet you again in another video, right? And in that I'll discuss the hard questions. Okay. Until then, thanks, and I'll see you again.